So let us discuss IPv4 addressing. The identifier used in the IP layer of the TCP/IP protocol suite to identify the connection of each device to the internet is called the internet address or the IP address. And we know that the IP address is of 32-bit addresses and it will uniquely identify each computer in the internet there. So as compared to the TCP/IP model or the OSI model, we see that the internet layer or the network layer is a common layer, and that is the one layer that identifies each computer or the node in a network uniquely. That's why it is called as universal address also, and it defines the connection of a host or a router to an internet. The IP address is the address of the connection, but it is not the actual address of the router or the node. Now, first we will discuss about the IPv4 addressing, which is a 32-bit addressing requirement. A protocol like IPv4 that defines addresses has an address space. So we will see that an address space is the total number of addresses used by the protocol. Then if the protocol is going to use B bits to define an address, then the total address space would be 2B bits, because each bit we can have only two different levels, that is 0 and 1 there. Hence, if we see IPv4 as compared to IPv6 or v5, it uses 32-bit addresses, whereas IPv5 uses 64-bit addressing and IPv6 uses 128-bit addressing. So for a IPv4 which uses 32-bit addresses, it means that I have an address space that is going to range over 2 to the power 232, that is nearly 4 billion addresses it supports. And if there were no restrictions, more than 4 billion devices could be connected to the internet. But some of the addresses are not being used for the unique address spacing, so they are being used for other purposes. So we will see how the addresses are distributed in an IPv4 addressing space. So coming to three different notations that we can use for IPv4 addressing. That is, first you have a binary representation. So you have four binary digits there which are of 8 bits each one. So this is the internal representation of the IP address. So since 32 bits are occupied, we can see that first byte 8 bits, second 8 bits, and third 8 bits, and fourth 8 bits, fourth one 8 bits. Totally it is leading to total 32 bits occupied for the IPv4 address. But binary representation is good for the internal representation of the computer. But as per human requirement, binary notation does not suit well. So we go for a next other representation or notation called as dotted decimal notation, in which case we are just representing each byte in a decimal form. So we can see that each decimal digit is separated by a dot. Hence it is called a dotted decimal notation. Now coming to, you can also go for the other representation in terms of hexadecimal. Instead of decimal numbers, each byte is represented in its hex form. Whereas in hexadecimal form, there is no dot that is represented between the bytes. So these are the three different notations called as binary, dotted decimal, and hexadecimal notation for the IPv4 addressing. Now, how the address is identified for a node in a network using the IPv4 address. As we have already indicated, 32 bits are used in order to indicate the unique address of a node or a computer. Out of these 32 bits, n bits are required or reserved in order to indicate the prefix which is going to talk about in which network the computer or the node lies, and the remaining 32 minus n bits are the suffix which will uniquely identify each node in the network. So you can see that the prefix is going to define the network part, and the suffix is going to define the actual connection of the node to the network. So we call this as a classful addressing, and we also have the another way of having an addresses for the IPv4 called as classless addressing. In a classful addressing, we will see that the prefix is fixed there. The number of bits used for the prefix is fixed there. So according to how many bits are allotted or assigned for the prefix, we have n number of classes, like in class A, class B, class C, class D, and class E. That is, when the internet started, IPv4 addresses was designed with a fixed length prefix, but to accommodate both the small and large networks, 3 fixed length prefixes were designated instead of 1. That is, you can allot 8 bits for the network, you can allot 16 bits, or you can allot 24 bits. The whole address space was divided into 5 classes called as namely class A, class B, class C, class D and class E, which will be shown in the next figure. So this scheme is referred to as classful addressing. So because the number of addresses in a classful addressing is going to belong to either to class A, class B, class C or class D. Although classful addressing belongs to the past, but it is going to help us to understand the next method of addressing called as classless addressing. Now coming to how the addresses are spaced in a classful addressing. So we can see that 50% of the addresses will belong to the class A, whereas 25% belongs to class B, 12.5% belongs to class C, 6.25 belongs to class D and 6.25 also belongs to class E there. So as coming to this picture, we will see that how do you identify the address belongs to a class A address. So in a class A address, the prefix length is of 8 bits, and among these 8 bits also the most significant bit is set to 0 to indicate that it is a class A address. So the remaining bits in the prefix may change from all 00 to all 11, and you can see that the suffix is allocated, wherein the suffix is going to indicate the number of nodes that can be present in each network. So it is of 24 bits. Whereas coming to class B, how to identify the addresses belong to the class B. So for the class B, 10 MS bit and the next bit is set to 0. So 10 indicates that we are already in class B addresses, and the remaining bits out of 16, 2 are fixed here, 1 and 0, and the 14 bits will be used to represent the prefix there. And as 16 bits are allocated for the suffix, 2 to the power 16 nodes can be present in any of the given network. Whereas coming to class C, to identify that this is a class C address, we assign 3 bits and fixed it as 110 there. And remaining bits, as 24 bits are allocated for the prefix, out of 24 bits, 3 bits are fixed as 110. So we are left out with 21 bits to indicate what network we can have. And the remaining 8 bits are the suffix, indicating that 2 to the power 8 nodes are possible in each of the network. Whereas coming to class D is used not for unicast addressing, that is one-to-one computer addressing, but it is used for multicast addressing. And in multicast addressing, the class D is identified by a fixed number of bits like 1110, whereas in class E, all bits, 4 bits are set to 1, and they are actually reserved for the future use. So this is how the prefixes are allocated to the classes. 8 bits for class A, 16 bits for class B, 24 bits for class C, and D and E, as they are not used for unicast addressing, they are used for multicast addressing, that is not applicable for the unicast addressing.